So energy is the total energy, right?
Yes,
So that shouldn't change.
exactly. Good. Total energy is always conserved.
So
Uh,
it's A.
A, right?
Okay. Why not B? Although A is the right answer. Why not B? I mean, why? How did you assume momentum is less than P naught?
Sir, because we know that the horizontal component will stay constant
Same.
in projectile motion,
Okay.
and but the vertical component will change, and
Hmm.
at the highest point it is zero, I believe.
What
So
is zero?
the vertical
Yes, it is zero.
is zero, right? So and when you're considering vectors, then it would be root of in horizontal and vertical square.
Fine. Correct. Anishka, what's your approach for less than P naught at the top?
Same, sir.
Okay, good. So the entire trick here is if the initial speed is u, so the horizontal component is u cos theta, and that will stay throughout the entire motion. So even at the top, you will have u cos theta. So let me write the momentum at the top will be mu cos theta, where mu is your original momentum. And then we just use cos theta is less than 1, and hence momentum at the top is less than p naught. But fine, your approaches are also correct. Option A. Moving ahead, next question. Okay, try this.
So is it C?
Check. C is 600. Explain.
So I just did, oh wait, 1 second. I forgot to consider friction.
Okay.
So does the graph consider friction too?
Let's see. In this graph, Anishka, the y-axis is horizontal force. So no, it's not considering friction. The graph is
Okay.
only for the force, horizontal force.
Okay, sir.
Sir,
Mm-hmm. Tell me.
no, I mean, well, the area under the graph would give you work, which is change in kinetic energy, but then that doesn't consider
Hang on.
friction.
How did you say area under the graph is change in kinetic energy?
It's work done,
Area under the graph is work done, but work done by which force?
the horizontal force.
Yes. See, let me write down. We will use the
Sir, is
work
it
energy
B?
1100.
500.
It is correct, Anushka. Good. Tell
Yeah.
me the trick.
I just did delta KE is equal to work done by all forces, work energy principle.
Yes.
I
So
forgot the frictional force initially.
good. It's fine. But now you understood. So Ahan, work done by capital F is your area under the curve.
Oh, yeah, fine, I got it.
Work done by friction you have to incorporate.
Which is 2 into 50 because, okay.
No, no, no. 2 into 50 into cos 180.
Ah,
Friction always acts opposite to displacement.
right.
That is equal to the change in kinetic energy. So solve this, Sahan, and check what do you get.
So I solved this before without the friction and I got 600, so it should
600.
be.
Even Anishka got that, but that's why I see all the IB questions are designed this way. So whenever you're solving questions, please slow down and think on the basics. The questions are not tough. It's just do not skip any point. Okay, moving on. Next question. No calculations, just conceptual.
So is it B?
Force that y exerts on x is less than f. So can you explain how?
Um, well, I went by like logic.
It's correct though, but do you have a reason? Can you elaborate?
I mean, so because they have differing masses,
Mm-hmm.
the force exerted, if it has to move both of the blocks,
Mm-hmm.
um, their acceleration will be the same, right?
Yes, good.
Okay, so then that's why the forces would differ.
Okay. Ahan, what about you?
Well, I was going with B, and my logic was, well, you consider them one big block. So its mass is y plus x for
Okay.
F. And then for the force that y exerts on x, wouldn't it just be the mass of x as the
Wait,
force?
let's revise the whole concept. So in this, if you consider y and x together, so Ahan, what's the forces acting on this entire system? Y and x together.
Mass of y plus mass of x into acceleration, right?
MA. So, MA you do not show in a free body diagram. You use that in the formula. In this, we want only the forces acting on it. So consider Y and X as one big system. What are the different forces acting on it?
mg again.
Downwards, right? So let's write My plus Mx into G. That's the weight. What else?
When normal reaction would be there.
Correct. And the third force is F,
F.
right? So what's the net force? Net force acting on this entire system.
Uh, add all the forces in respective directions, right?
See the normal reaction and the weight, they cancel each other out.
Yeah.
So you delete them all together. The only
It's
force
just
left is F. The net force is F. Now this is your free body diagram if you have combined it, Y and X, right? Now if we draw a separate free body diagram only for X. Okay, now Anishka, tell me the different forces acting on X, only on X.